to find the equation of a quadratic from its given roots, you kind of are working backwards a little bit. But the best way to do this is to actually use the sum and the product of the roots. Because we have the two roots, we could easily add them together to get the sum. We could multiply them together to get the product. So let's start there. So for my first example, if my roots are 4 and negative 2, the sum of the roots is going to be 4 plus negative 2 is 2. And the product of the roots is going to be 4 times negative 2, and that's negative 8. Now, there's two ways I can go about this. I could recognize that this comes from negative b over a and c over a, and just kind of put them over 1, and I'll see that means, oh, well, that means that a equals 1 and b equals negative 2 if negative b equals positive 2, and c is going to equal negative 8, and then plug that in to be x squared minus 2x minus 8 equals 0. But the other way of doing it also is I actually think a little bit better. So you could use this concept of c over a, but let me do it another way. That my sum is 2 and my product is negative 8. And so a really easy formula to remember here is that all quadratics go the x squared minus the sum of the roots x plus the product of the roots equals 0. And so I'm just going to substitute this in. That's going to be x squared minus the sum. Now the sum is 2, so minus 2x, and plus the product, plus negative 8, we just write as minus 8. And that equals 0, just like that. And it could easily be checked by doing negative b over a to see that my sum is 2, and c over a to see that my product is negative 8, or I could factor it or the quadratic formula to find the roots and check that my roots are indeed 4 or negative 2, or I can use the calculator to help me find those also. So that's pretty simple, and it's really not more complicated when we have complex roots like 2 plus 3i or 2 minus 3i. And we know that usually comes from the quadratic formula, but we're still going to solve this the same way. We're going to use the sum, which will be 2 plus 3i plus 2 minus 3i. And don't worry, it's actually very simple because your I terms are additive inverses of each other. They cancel each other out. So we end up with just 2 plus 2 is 4. And the product isn't too bad either, 2 plus 3i times 2 minus 3i, because these are conjugates of each other, and I don't need to do the whole FOIL because my middle terms cancel out anyway, so I really just need to do first, which would be 4, and last, positive 3i times negative 3i, negative 9i squared, and remember that that's going to turn into a plus 9 because I squared means times negative 1. Anything with an I squared attached to it gets times by negative 1 and ultimately changes sign, so 4 plus 9 is 13. So the sum and the product for complex are really quite simple. The sum is easy because your complex parts cancel out, and the product isn't too bad because since they're conjugates, you don't need to do all 4 terms of FOIL because the 2 middle terms will end up being additive inverses. And in this particular case, we would have had a negative 6i and a positive 6i, which would have canceled it out anyway. So recognizing the conjugates is very helpful. And so then plugging this into our formula from over here is x squared minus the sum x minus 4x plus the product plus 13 equals 0. And that's it.